a biochemist. My name is Nicole and I'm your host for today, and let me introduce you to our teams. Team Krebs. Team Hasselbach. Very well. Now let's get started. Question number 1. What is an alpha amino acid? A. Amino acids that have a carboxylic acid group bonded directly to the alpha carbon. B. Amino acids that have an amino group bonded directly to the alpha carbon. C. Amino acids that have an alpha carbon that is not a chiral center. Or D. Glycine. Which is... Team Hasselbach.
B.
Ding, ding, ding. Very good, Team Hasselbach.
Yes,
1 point for you guys.
Alpha amino acids are amino acids that have an amino group bonded directly to the alpha carbon. As you can see, every alpha amino acid has an alpha carbon bonded to a carboxylic acid group, an amino group, a hydrogen atom, and an R group that is unique for every amino acid.
Question number 2. There are 20 common amino acids and they are classified in 5 groups depending on their side chain. A. Non-polar alkyl, polar aromatic, neutral, acidic, and basic. B. Non-polar alkyl, non-polar aromatic, neutral, acidic, and basic. C. Wrong, they are classified in 6 groups. Or D. Polar alkyl, polar aromatic, neutral, acidic, and basic. Team Krebs.
A.
That is not correct. Team Hasselbach.
B.
Ding, ding, ding. Very good.
Yes.
Team Hasselbach. 2 points for you guys. Team Krebs, 0.
There are 20 common amino acids. Based on the R group, they can be classified in 5 groups. Hydrophobic amino acids have 2 groups, non-polar alkyl and non-polar aromatic group. Hydrophilic amino acid has 3 groups, polar neutral, polar acidic, and polar basic.
Question number 3. A peptide bond is formed between blank and releases a molecule of blank. A. 2 amino groups releasing carbon. B. A carboxyl and an amino group releasing H2O. C. 2 carboxyl groups releasing oxygen. Or D. An ester group and an amine group releasing H2O. Team Krebs.
B.
Very good! Team Krebs finally scores the point.
Yes.
It is now 1-2. Question number 4. What does the charge of the amino acid depend on? A. The charge on the amino acid side chain depends on the pK of the amino acid and on the pH of the solution. B. The temperature. C. Only on the pH. Or D. None of the above. Team Krebs.
A.
Very good. Team Krebs scores another point, and it is now a tie game, 2-2.
Among the 20 common amino acids, 5 have a side chain which can be charged. At pH 7, 2 are negative charged, aspartic acid and glutamic acid, and 3 are positive charged, lysine, arginine, and histidine.
Question number 5. What do titration curves show? A. The electronegativity of an amino acid. B. How the pH of a solution changes with the amount of OH or equivalent added. C. The strength of the different bonds between amino acids. Or D. How the ionization of side chains of amino acids affects its pKa. Team Hasselbach.
A.
Incorrect. Team Krebs.
B.
Very good. Team Krebs takes another score, and it is now 3-2.
An acid-base conjugate pair can resist change in the pH of a solution by acting as a buffer. The buffer maintains the value of the pH near the pKa of the acid component of the buffer even if protons or hydroxide ions are added. The titration curve is a plot of how the pH of a solution changes with the amount of OH- added. This shows that the addition of a large amount of OH- to buffer produces little change in the pH of the system. The inflection point is at the point where the pKa and pH level are the same. Inflection point on the graph is where all of the starting solutions, usually an acid, has been neutralized by the titrant, which is usually a base. To calculate the acid dissociation constant, pKa, One must find the volume at the half inflection point, that is where half the amount of titrant has been added to form the next compound. Henderson-Hasselbalch equation uses pH as a measure of acidity. Using pKa, the negative log of the acid desiccation constant, in biological and chemical systems. Titration curves can be useful for estimating the pH of a buffer solution.
Question number 6. What is the inflection point? A, the point when the pH is neutral. B, the point where the pKa and pH levels are opposites. C, the point where the pKa and pH levels are the same. Or D, the point where amino acids have no net charge. Team Hasselbalch.
C.
Correct.
Yes!
Team Hasselbalch is now tied with Team Krebs. Question number 7. The isoelectric point of an amino acid is the pH at which the amino acid has A, neutral charge, B, negative charge, C, positive charge, or D, none of the above. Team Hasselbalch.
C.
Incorrect. Team Krebs.
B.
Incorrect. The correct answer is A, neutral charge. So now we are on question 8, which is the tiebreaker. Let's see who takes the win. When we calculate the isoelectric point, we A, calculate the sum of the neutral charges plus the positive charges divided by 3. B, calculate the sum of the negative charges plus the positive charges divided by 2. C, calculate the sum of the positive charges divided by 2. Or D, calculate the sum of the negative charges plus the positive charges divided by 1. Team Krebs.
B.
That is correct, and we have...
The isoelectric point, pi, of a peptide is defined as the pH at which the peptide has a net charge of 0. At pH values below the pi, peptides carry a net positive charge. Above the pi, they carry a net negative charge. Various acidic and basic functional groups on amino acid side chains and termini of proteins and peptides may be charged. The presence of a charge is dependent on the pKa values of the groups and the pH of the solution.
Thanks so much for watching. See you next time on Are You Smarter Than a Biochemist?